Hey, y'all. Welcome back to yet another amazingly wonderful day in the Science Center. Today is Wednesday. It is April the 6th of 2022. Wow, this year is already like rocking and rolling. I don't know about you guys, but I feel like it's going by super duper fast. Okay, so taking a look at our calendar for today, there are most of you guys that have turned in number 37, and we're going to be going over that today. So that is what is keeping us on schedule right here. And then tomorrow and Friday, we're going to be going back to our ride designs. Okay, so let's go over and start talking about this study guide. So where you guys found this was it was right here in Google Classroom, and it essentially said for you to open it up, fill it out, and then turn it in with a private comment. I've gone in and graded everybody's so that everybody gets the appropriate grade for their effort level. So let's start going over all of these answers so that we make sure that we understand everything. Okie dokie. So the multiple choice were pretty straightforward, but number one, the sum of kinetic energy and potential energy, those things combined are, of course, mechanical energy, something that is actually moving. Alrighty, then number two, potential energy is, and yes, it is A, that it is just stored. It has the potential to actually start enacting some sort of energy. All right, number three, kinetic energy is boom. Number or letter B, it is the actual moving energy when something is in motion. Alrighty, then number four, which of the following is not a type of potential energy? C, kinetic, because kinetic means it's moving. Therefore, it can't also be potential. And then number five, where would a roller coaster have the greatest potential energy? All right, so if you think about all of those little graphs and whatnot that we have looked at and the graphics that we've looked at, think about the top of a roller coaster. The top of a roller coaster, right before you go over the edge, you are going to have an insane amount of potential energy. Alrighty, so that is why that one is A. Alrighty, so now let's take a look at the fill in the blank. Alrighty, so number six, it says that we have two trucks that are moving at the same velocity, which is the speed plus the direction, but that they have two different masses. Truck number two is at 500 kilograms, as where truck one is at 200. So if we think about that calculation, 1/2 mv squared, well, there's an m in that, and that m stands for mass. So the larger the mass, the more kinetic energy they're going to have, which is why that answer is 2. All right, number 7, when an object like a ball falls, some of its blank energy changes to blank energy due to the conservation of energy. Yes, so before the ball is falling, it just has potential energy, and the second that it falls off of wherever it was, then it turns into kinetic energy. Already, number 8 says this type of energy will be the highest at the bottom of the swing's path. All right, so think oppositely of the roller coaster. So when the roller coaster gets to the bottom, like the very, very bottom of the ride where it's about to go back up a hill, it would be in this same situation as number 8 is referring to. So the kinetic energy at the very bottom of a dip is going to be the highest. Alrighty, and then number 9, this type of energy will be the highest at the top of the swing. And yes, that would be exactly the same scenario as the roller coaster up at the top of the hill. All right, now looking at the energy transformation section, it said that we are supposed to explain what's happening here. And these answers are very shortened, of course, but if I were to ask you this in a test type situation, I would want you to actually explain it using words. Okay, so number 10 is a toaster heating up Eggo waffles for breakfast. Okay, with the toaster, you're going to have to have plugged it in, so that would be your electrical part. And then you're actually heating the Eggo waffle, so of course it's going to be thermal. Alrighty, then number 11, it says we have a student that plays a piano in music class. Alrighty, so we're going to have the actual kinetic movement of the piano keys, and that is going to then, of course, change over into sound. And now let's go down into our calculations. Okie dokie. So, just like before, when we've had problems with this material, we have to think about the fact whether or not it is moving. Because if whatever it is and the problem is moving, then we have to do the kinetic energy calculation of 1/2 mv squared. And if it is just sitting there, it is gravitational potential energy. And we do this calculation of ham. Alrighty, so taking a look at number 12, it says we have a rock that is sitting on the edge of a cliff. Okay, that one is not moving at all, so we just plug everything into ham. And keep in mind that we are still dealing with our standard acceleration, which is 9.8 meters per second squared. So we plug in our h, our a, and our m. And as long as you type that into your calculator or you ask Siri to help you along your merry way with it, then you should have gotten 7,350. And you have to make sure that you put that is joules so that we know that it's not cows and pigs and chickens. Alrighty. Number 13 says if we have a toy helicopter that is moving, all right, that right there told me that it was going to have to be 1/2 mv squared because it says that it is actually moving. All right, so it's moving at 12 meters per second and it is 3 kilograms total. All right, so we have our 1/2 mv squared, our m is the 3, and our v is the 12. So remember, the 1/2 is like 1/2 3, which would be 1.5. And then we have to do 12 squared, which is 144. And then that leaves us with 1.5 times 144, which if you typed that incorrectly is 216, and it has to be joules.